Today we're going to learn about quadratic functions and equations. We're going to learn how to factor quadratics, how to factor quadratics when a is greater than 1 and when a is just equal to 1. We're also going to go over the quadratic formula. There are some different rules when we factor. We can factor things like difference of squares, perfect trinomial squares, um, and finally the quadratic equation. We might skip over a couple of these methods because ultimately the quadratic equation will allow you to solve uh, any of these problems. So a quadratic is in the form ax squared plus bx plus c. It can have 0, 1, or 2 solutions in it. Uh, the the basic formula is we do a times c, and then whatever that value is, we want to figure out what are two things to multiply to get a times c, and they add up to the value of b. This is when a equals 1. Um, so we look for two numbers to multiply and add to b. Let's call them m and n. You can factor them into something like this. So when you find those two numbers, when the leading coefficient is equal to 1, you just write x plus the number quantity times the quantity x plus the other number, and that equals 0. And then we use the zero product property to solve for what x is. Let's take a look at this example here. So here we have x squared minus 5x minus 24. In this case, a equals 1, b equals negative 5, and c equals negative 24. So the first step, we're going to do a times c, and that equals 1 times negative 24. A times c is negative 24. Now we're going to list all the factors of negative 24. So this is negative, well, we'll start with actually just 1 times negative 24. That's the first one that we've already written there. 2 times negative 12. 3 times negative 8. 4 times negative 6. And I believe that is all of them. Now we have to write the other way also. So negative 1 times 24. I should put the negatives in parentheses. Negative 2 times 12. Negative 3 times 8. Negative 4 times 6. And our value of b equals negative 5. So we are looking for which of these factor pairs, if we added them together, equals what b is. So b equals negative 5. So now instead of multiplying these, we're just going to look to see what would it be if we added them. So the answer for this one is 3 plus negative 8 gives us negative 5. So we can just write this out like this. X plus 3, quantity x plus 3, times quantity x minus 8. And that's how we write this in factored form, given the quadratic equation. This is called the AC method, or just factoring a quadratic. Once you get to this form here, you want to actually solve for what x is. So if you were to graph this on a graphing calculator, you would get a parabola, and that parabola is going to open up. If you were to graph this on the graphing calculator, you would get the exact same parabola. Because if you were to multiply these out, you'd end up with this answer. So it's kind of like going the opposite way from multiplying. Um, so that's what factoring is in a sense. Now, these answers for what x is, these are called our x-intercepts. And those are located on the x-axis. So this one is x equals 8, or 8 comma 0 for this first one here. And the second one is x equals -3. So that's -3 comma 0. So that's how you find the x-intercepts is you set these factor groups or these binomials equal to 0. And then you solve for what x is. So we just have x minus 8 equals 0. That's really simple. We're just adding 8 to both sides, and that's how we get x equals 8. Now, this was a nice formula. It worked out very well because a equals 1, and we were able to find what factor pairs add up to equal b. So we were able to factor this. Difference of squares is a rule I think it's worth memorizing. It's if we have something where it's like something squared minus something else squared, then it's the first term, the square root of the first term plus the square root of the second term, quantity times the quantity of the square root of the first term minus the square root of the second term. So let's look at a quick example here. 36x squared minus 1/9. So the first thing we're going to do is we're going to find the square root of each of these. So the square root of 36x squared is 6x. So we write those there for our first term. And then the square root of 1/9, that's the square root of 1 over the square root of 9, and that's 1 over 3. And so in this case, if we're using x and b, like for up here, we could say that 36x squared for our example equals x for up there, and that 1/9 is equal to 1/3. And I was actually, hold on just a minute here. I didn't write that correctly. 36x squared equals x, and 1/9 is equal to b. Still not correct. 36x squared equals our x squared, and 1/9 equals our b squared. So when we write this out, let me write this out a little bit differently here. So we have x squared minus b squared equals x plus b, x minus b. So our x squared is going to be 36x squared. And normally we don't use x and x twice. That's why I got a little bit confused here. And minus b squared is minus 1/9. Now we do the square root of 36x squared, and that's going to be what x is. So that's just going to be 6x. Square root of b squared, square root of 1/9, which we just found out was 1/3. And then we're going to do 6x minus 1/3. So that's the pattern for difference of squares. It's a fairly simple pattern. But again, I got a little bit confused there when I saw when I was comparing 36x squared to x squared. That was not technically correct. We shouldn't usually do that with variables, using them with variables like that. I should have used a different letter. Factoring perfect square trinomials. This is another good rule to memorize. So when you have a quantity squared, that means that you have something in parentheses and it's squared. That means that we're multiplying those two terms by themselves. So it's squaring this entire section, this entire binomial. And when we do that, we get x squared plus 2xb plus b squared. Now, the reason we do that is from the distributive property. So this is x times x is x squared, x times b is xb, b times x is bx, or also written xb, because you can multiply in any order, and then b times b is b squared. So now we have x squared plus, there's two xb's there, so it's 2xb, and then plus b squared. This is worth memorizing for anything that's any binomial that is squared. All right. The quadratic formula. Sometimes it can, if this formula is difficult to remember, sometimes people learn it in a song format. And you can look up quadratic formula songs on the internet and find a song that maybe helps you to remember the formula. Um, but it basically it solves for what x is for us. So one of those previous problems we had x plus 8 was one of our factors. We set that equal to 0, or maybe it was x minus 8. Anyway, if one of our factors is x plus 8 and we set it equal to 0, we can minus 8 on both sides and we get x equals -8. When we do the quadratic formula, we get this answer here. We do not get the factored answer. We get what x equals right away. So this is our quadratic formula. Underneath the square root, this is called the discriminant. It is a great idea to solve for the discriminant first, because once you have that part done, the rest is pretty easy. And we also have a plus or minus here. The plus or minus indicates that it's a square root. When we take the square root of any number, it can be positive or negative. So the square root of 4, yes, it equals 2, but the square root of 4 also equals -2. So we don't often learn this in school. We most of the time just learn square roots of positives, but everything has a negative value as well. And so that's where the plus or minus symbol comes into play. And because of that symbol, we have two answers for x. Sometimes these two answers for x can be the exact same answer. If that's the case, then we just have one answer. We'll look at an example for the quadratic formula next. So I like to write out what A, B, and C is. So A is 6, B is -5, and C is -4. So we can write out the quadratic formula. It's minus b plus or minus the square root of b squared minus 4ac all over 2a. So minus b is -5, so that's +5, plus or minus the square root of b squared is -5 squared minus 4 times 6 times -4, all divided by 2 times 6. So now this is 5 plus or minus the square root of, now let's do the discriminant first. -5 squared. If you type that in your calculator without any parentheses, you might get -25. In fact, I just did on my calculator and I got -25. -5 squared is -5 times -5. A double negative gives us a positive value. And so that's going to be 25. Anytime we square a number, it is always going to be positive. Now let's look at the number of negative signs we have here. -4 and a -4. So let's treat this like we're adding all of this stuff over here. So this is -4 times 6 times -4, and that equals a positive 96. So now we can figure out what the discriminant is. This is 2 times 6 on the bottom on the denominator, and then we can write this as 5 plus or minus the square root of 25 plus 96 is 121, all divided by 12. And I like to write like 2 arrows like that for my 2 answers. We're running out of room here, so I'm just going to write the answers over here now. I'll put x1 for our first one and x2 for our second answer. So for x1, it is going to be 5 plus the square root of 121, all divided by 12. And for x2, it's going to be 5 minus square root of 121, all divided by 12. So for x1, this is 5 plus the square root of 121 is 11, all divided by 12. X1 is 16 over 12. And we get a repeating decimal. We get x1 is 1.33333. If we divide this by 4 over 4, we should get 4/3. That's the value of x1. For x2 is we're going to subtract it. So for x2 is 5 minus 11 over 12. X2 is equal to negative 6 over 12. X2 is equal to negative 1/2. So those are our values for the quadratic equation. Now, they solve this without the quadratic equation for this part. Let's take a look at what they did here. So instead of the quadratic formula, you can do something where you can factor by grouping. Um, this gets a little more complex. I would just say you can use the AC method again rather than doing this split the middle formula. Split the middle is basically the AC method. So let's go over how to do that without the quadratic formula next. A lot of students tend to lean toward the quadratic formula because it works every single time, and you don't have to memorize all the rest of these formulas. But if you did want to solve this without the quadratic formula, if you are dreading solving with quadratic formula, you can solve this way instead. So A is 6, B is -5, and C is -4. So now if we do AC, that's going to be 6 times -4 is -24. And we can write all the factors out for -24. And I believe we did this in the last problem even, on the problem above. And then we do the same thing for these here. Like that. Okay, now we want to figure out which ones add up to -5. And that is, again, 3 and -8. So what we're going to do, instead of just writing like before, we wrote x plus 3 and then x minus 8. Instead of doing that, we're going to write it out. We're going to split this into two pieces. So it's 6x squared. Usually we write the smaller, well, I'm just going to write it like this. I'm going to say plus 3x minus 8x minus 4. And I wrote it like that because I wanted to put the 6 and the 3 together because those are, we can have a common factor with 6 and 3. I also wanted to put the 8 and the 4 together because they share a common factor of 4. Now we can split this in the middle. And this is called factoring by grouping. You can group that and you can group this. When you group those, make sure you put a plus between them. If you don't, then it's not a correct mathematical statement and it's just multiply, and that's not true. So these are 4 different terms. We're putting parentheses around them, putting a plus in between. Now we're going to figure out what's the greatest common factor from the first part. What's the biggest value we can divide by? And that is going to be 3x. We can divide both of those by 3x. That's the largest value of a numerical value and the largest variable value that we can divide by. And now we're left with 2x plus 1. Now, because we've written that there, we're going to write that same thing over here. We want those to be the same. And we've got to figure out next what number goes here in order to, if we multiplied it back out again, it would equal all of this stuff. So let's think about this for a moment. -8x is our goal. 2x times what is -8x? It's going to be -4. And we can check the second term as well, the -4. -4 times +1 gives us -4 if we were to multiply that out. Now we merge these two together. And then this becomes a binomial as well. And now we're multiplying these together. And we're left with that. Once we have these sections, we set it all equal to 0 because it was set equal to 0 to begin with. So that means that 2x plus 1 equals 0. Divide by 2 on both sides, and we get x is negative 1/2. And it also means that 3x minus 4 equals 0. So 3x equals, add 4 on both sides, 3x equals 4, and x is going to be 4/3. So we get the same answer from these. It just really depends on what method that works best for you. And that's why I show students both of these methods, because ultimately we're finding the same information, but in two different ways. Now, on the SAT, they're going to say, sometimes they're going to put those answers as the answer, but they're going to ask you something completely different. They're going to say, what is the product of the solutions? Or what is the sum of the solutions? So in this example, our solution was negative 1/2 and 4/3. If we wanted to find the product, we just would multiply those straight across and we get negative 4/6, and we can reduce that fraction to negative 2/3. So that would be the product if we multiplied these two answers. And we can also add them as well. And I'm not going to go over adding fractions, but that's what they're going to be asking you on the test. Now, this is the quadratic formula, and we just went over that in the last part there. So again, whichever method works best for you, I would say, for the test, go ahead and do that. And then also, you can use answers to plug in the answers and see if they make sense. So you might have multiple choice of x equals 4/3, x equals 1/2. Maybe you forget the quadratic formula and how to factor completely, and you don't remember either one of those ways. You can plug in what x is, and you can see if it makes a true statement. So if you plug in 4/3 for x here, you should get 0. And if you plug in negative 1/2 for x here, you should also get 0.